All right, Yahoos. Sorry I couldn't be here with you today. I've been called out on duty. You're going to be checking a little review for the energies and fuel test tomorrow. I'll be back for that. I can't pick up your labs because I'm not here, but you put them in electronically tonight in the VLE, or give me a physical copy tomorrow before the test. Cool? Your review is on the VLE. It looks like this. Apparently I threw it. And it's just some questions to give you a chance to see what we'll ask you on the test. So they're for you to work with your partners and look in your notes and all of that good stuff. I'm a terrible copy jockey, so they're kind of all over the place, but you'll be fine. That's up on the VLE. There's another one also up on the VLE, but just this one, it's number 2, is obligatory. Cool, so try that out today. Also coming back are your quizzes, and I'll describe those now. Cool? So grab your safety glasses and let's get rolling. All right. In the quizzes, you'll see that there's a whole bunch of space on that first page, and it's really there for you to tell me what you know. Right? So I stole my favorite response. I won't tell you which student it is, but it's right there, and I cut the name off, and you know who you are. So I took that response. So I wanted you to see what somebody actually wrote, and I took a few things out and added a few things in. I won't bore you by going through the whole thing. Read it. It's not a bullet list. I'm not looking for a bulleted list, right? I know what an atom is, and I know that you know what an atom is. But how do molecules and atoms and bonds and electrons all connect, right? It's in here. Talk about that. Also discuss, right, the figures. Man, we're still having a hard time with this. We go from lower energy state to a higher energy state. Energy's got to be going into this thing, right? It's got to be going in. So where does the energy come from? It comes from the surroundings. It comes from the water, right? It's going in. This is endothermic, which means that if it's coming from the surroundings, this gets cold. Endo means cold. It's going in. This is alternately, it goes from high energy products to low energy, higher energy reactants to low energy products. Energy comes out, right? This used to have more energy, now has less. Where does it go? It comes out. So this is exo. Exo means out, right? And this gets hot. We're still having a problem with that. We got to fix that. Also, it's not just that when we break bonds that energy has to go in. Yeah, that's true. We have to break bonds for energy has to go in to break bonds. But once they're broken and they reassemble, right? Once they reassemble, energy comes out. And it's the difference between this and this that determines if it's endo or exo. Cool? So that should make more sense if you read through that, right? Great, fine. Moving on to the calculations. There were 2 versions. One was version 1 and version 2. I'll look at both of them. One's here, one's here. With both of these, you have to balance the equations. I gave you some place to start, and you also have to balance this Lewis diagram. So we figure that in this, I think this is quiz 2, that you have 1, 2, 3, 4, 5 of these HC bonds, 1 C to C bond, 1 C to O bond, and 1 O to H bond. And all of these tell you how much energy it is to break apart one of these, right? Also, we have oxygens to break apart, and we have 3 of those molecules. So I know that there's only 1, but we're multiplying by 3 here. So if you see a waterfall like this on your page, it's because you didn't multiply, you didn't multiply this value by how many of them you have to break up. So that was a common mistake. So like here in the CO2, I know that each one of these CO double bonds is 799, so that's why I have 1, 2, so that's this 2. but I have 2 molecules of that, so that's this 2, right? Same thing here. I know I have 1, 2 HO bonds, and that's this, but I have 3 of those molecules, so you multiply them, add them up, and this is how much goes in, this is how much comes out. In total, you have more out than in, so this ends up being negative 1,000, well, yeah, negative 1,255 kilojoules per mole. In the other one, it's the same sort of thing. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 HC bonds, 4, 1, 2, 3, 4 CC bonds, and you only have 1 of those molecules, right? So this should be like a 1 in front. This is 8 of these, 5 of these, 6 of these, etc., etc. Well, somebody did a really nice job with those. And you're just looking at the difference. The change in enthalpy, delta H, is really talking about the energy going into the bonds, right? So you should be getting a negative answer to say that there's negative energy going in, which means energy coming out, which means exo, right? Exothermic, if you have a negative energy. Neat. That's the basic idea. Check each other's calculations, run through it again, make sure you can get these numbers, and we'll go from there. I'll see you tomorrow for the test. Bum, bum, bum.